Hello, my name is Sylvia Ch.8, and as you can see, I'm doing a reassessment for Chapter 8 in physics. So I got this problem out of the book. It is 8.x.16. Basically, it tells you have a hydrogen atom, and the ground state for a hydrogen atom is n equals 1. So part A says if the hydrogen atom is in its state n equals 4, what is K plus U for this atom in electron volts? So you take the formula for energy of a hydrogen atom, which is negative 13.6 electron volts divided by the energy state squared. So if you're in the fourth energy state, you take this negative 13.6 and divide it by 4 squared, and you get the energy of the hydrogen atom in that state. Then part B asks if the hydrogen atom transitions from the energy state of n equals 4 to n equals 2, what is the energy now for this atom? So what is K plus U for this atom? Well, if you use the energy principle, you have the change in energy is equal to the final energy minus the initial energy. So your final energy would be when the atom is in n equals 2. So you use your formula for the hydrogen atom energy, and you have negative 13.6 over 2 squared electron volts. You subtract that by the initial energy state it was in, which would be n equals 4. So the change in energy when you transition a hydrogen from energy state 4 to energy state 2 is negative 2.55 electron volts. Then in part C, it says what is the energy in electron volts of a photon from the energy state n equals 4 to n equals 2. So this is basically the same as part B, except for when the hydrogen atom went from the energy state of n equals 4 to n equals 2, it gave off a photon. So the photon now has an energy of 2.55 electron volts, and you get that by taking the state that the hydrogen atom was in, which would be n equals 4, and then subtract that from or subtract that by the state that the atom dropped down to, which is n equals 2. So when the hydrogen atom dropped to a lower energy state, it emitted a photon which had a positive energy. But when you calculate the energy of a photon of the hydrogen atom in part B, you get a negative energy because the energy decreased for the atom, whereas the photon that was emitted had a positive energy. Then part D asks, it gives you this nice little picture, and it says which of the arrows in this figure represents the transition. I assumed that it was asking about the transition in part C of the photon, and the correct answer would be this arrow, which is number 5, and it shows you that it goes from energy state 4 to energy state 2, and that would give you the positive 2.55 electron volts, which is what the photon's energy was. Okay, that's it.